KCSE Math
Hello
Paper
friends, look
1
at this question.
2016 Quiz
In the
20,
diagram below,
2006
the
Quiz
coordinates AB are
22,
given as
Vector
follows.
1, Form
The point
2.
N is on OB. You can see the point N is on OB. And 30N, 3ON is equals to 2OB. So 3ON is equals to 2OB. Yeah. Therefore, it means that if I want to find N, just for a case here, for an example, 3ON is equals to 2OB. If I want to find N, I'm going to divide by 3 by 3. Therefore, ON will be 2/3 of OB. And the coordinates of OB is here. Therefore, we are told to find the vector Ln. So to find Ln, if I'm standing at L, I want to go to N, I'll simply have to come through LO first. You can see against the arrow. Then I go from O to N. These ones are capitals. So Ln, LO, I don't have point L, and point N, you can see I can get it from this information here, 2/3 of OB. Therefore, point N will be 2/3 of 15/6. Therefore, if I do here, I have 10, and the other one I have 4, goes to there 4. So ON, this point here should be 10, 4. So let us look at an instruction given to find L. It told that line ON is produced at L such that OL, it is 3 of OA. So I just have to multiply the vectors of A, the points of A 3 times. So L will be 3, then 3 times 6, that's 18. That's the point of L. So to come back to my equation, I'll say LO, which is L first. LO is the same as L O minus L plus N minus O. Therefore, O it is 0, 0. Minus L, it is 318. This one I'm supposed to add to N, which is 10, 4. Minus 0, 0. So I have negative 3, negative 18. Plus 10, plus 4. Therefore, the vector of Ln should be negative 3 plus 10, that is 7. And negative 18 plus 4, that is negative 14. So this is the point given for Ln. We look at the next part. Given that M is the midpoint of Ln, look at Ln. M is midpoint here. M is a point there on a line such that Lm, Mn, Lm, Mn has a ratio 3:4. So I'm going to indicate the ratios there, 3 and here 4. So you're told to find the coordinates of M. So how do we go about coordinates of M here? So because already I have L, N, yeah, I already have Ln, it's here. So what I'm going to do, because to stand at this point, I'll just say that point M is equals to the ratio 3 over the total ratio 3/4, which is 7. The ratio of that, of the line, 7, negative 14, because this is the line Ln and M is just on the 3/7 of it. Therefore, if I press that, I'll be having my answer as what? This one will go here 3 times. This one will go here 2. Negative 2. Negative 2 times 3. I have 6. This one is not my exact answer because I'm supposed to be adding on the vector L, which is 3 18. It's a negative here. Therefore, my answer will be 6, negative 12. Alternatively, just let me look at an alternative method. I am from point O and I want to go through point M. So how will I go through that? It will be OL plus LM. That's why you find I'm adding the point here. So for the one that I found the first part, it was the point LM. So this is LM, just to avoid confusion. Then the what I added here was the point OL. Therefore, to find point M, I'm going to take LM plus OL. And that is the alternative method in which you can use to get that value. You are further told that if line OM is produced at T, such that OMMT is equals to 6 is to ratio 1. So let us look at that in the diagram. Line OM is produced at T. So we have line OM. Or there's a line produced here extending. So this is point T. And the ratio, it is 6 is to 1. So what does that imply? Just going to try to frame this one here. This is our point T. So it means that the points I have in L, there are 6 times from this distance to here. So if point M, it was 6, 12. Point M itself, it is 6, 12. And the ratio, it is 6 is to 1. So where, if this has 6, the other one should be having 1. What about if it is negative 12? The other one should be having negative 2. So that is the distance from M to T. This is the distance from M to T. Therefore, if I want to find the vector T, I'm going to find the sum so that I can have OT. That's the position of T. So if I had here, you have 7 and negative 14. Or on other hands, you can still say 6 plus 1 and 12 plus 2. So that you have the positions as 7, 14. So the next part, you have to show that the point L, T, B are collinear. And if I look at the line on the diagram, L was somewhere there, T was somewhere here, and B was here. The coordinates of L, it is 3, 18, T I have, and 15, 6. So let us substitute that. We have 15, 6 here. T, we have gotten our value there as 7, 14. And L, we have a value as 3, 18. So to find points that are collinear, we just have to take one common point and say, for example, I take my common point as L. So LT should be equal to the point TB, because I'm comparing L with all the 2 points. So this is the same as T minus L is equals to B minus L. So T, it is 7, 14. I subtract that to L, 3, 18. This one should be equal to B, which is 15, 6. I can subtract this to L, which is 3, 18. So if I do this side, I'll have 4, and the other one I'll have negative 4. This is the line LT, and the line LB, if I subtract 15 minus 3, we have 12, and 6 minus 18, we have negative 12. So what do you realize here? That there's a certain number, if I multiply, I'm supposed to be getting 12. If I multiply it by this side, I'm supposed to be getting 12. Which number is that? 3. Therefore, 3 times LT, I'll be getting LB. So I'll conclude by saying that L being a common point, therefore the points are collinear. Thank you very much.